Okay. All right. So I hope that you're able to hear me. Okay. I'm in a large room that has quite a bit of an echo, but hopefully you can make out what I'm saying here. So, what I wanted to do was talk a little bit about your question about determining the difference between the absolute minimum and maximum and local minimum and maximum. And I wanted to do that by highlighting a couple of problems or a couple of functions to sort of illustrate the difference. So, the first example here, and don't worry too much about the function itself, um, what the function is, but it's just to draw out the differences. Those are the things that I want to actually begin to illustrate. So, in a function, or when you look at the graph, you'll see like hills and valleys, ups and downs. And so, we refer to those hills and valleys as minimum and maximum points. So, now a local minimum or a local maximum is going to be basically a high point in the graph. So in the instance of this graph, we see that we have a point here, negative 1.78, 9.548. That's a high point of the graph. Now, it's not an absolute maximum because it's not the highest point in the graph of the function. If we follow the function all the way through, we see the graph does tend to increase without bound, goes up forever. So this will be considered a local maximum, not an absolute maximum. Another local maximum is located here at 0.764, 2.254. Okay. It's not as high as the previous one, but because it is a high point in the relative region, we consider that to be a local maximum. Now, this graph has two local minimums. We have one here at negative zero point 0.4 and a second local minimum here at 1.432, where x is 1.432. Now, usually when we locate where minimum values occur, we may express it in terms of the x coordinate unless we want to give the entire coordinates of the point. But these are going to be local minimums. Now, they're not absolute minimums because they're not the lowest point of the graph because the graph extends infinitely downward. But because they're like sort of dips in the graph of the function, we refer to those as local minimums. Now, a second example of a function hopefully will highlight the difference here. So if we take a look at this function, we see that we have one local maximum located here at 1.35 and 5.415. And there's a local minimum here at 3.343. Now, this graph also has an absolute minimum, which is located at the endpoint at 0, comma, negative 3. When you look at the graph of a function, you want to pay attention to see whether the graph is understood or assumed to extend infinitely to the left or to the right, or whether there are clear endpoints. Now, I believe that your problem had some clear endpoints. So the endpoints can be regarded as being absolute minimums or absolute maximums if they represent the lowest or the highest point in the entire graph. So this example has an absolute minimum of 0, negative 3, and a local minimum of 3.343. Has a local maximum at 1.35, 5.1 5.415, but no absolute maximum because the graph, from what we can see, extends upward infinitely. So I hope that this gives you a little bit of insight about local and absolute minimum and maximum points, and that can help you to understand how to approach the problem that you're looking at.